Well, a warm welcome to everybody and good afternoon. Together with my two colleagues, I have the pleasure to share you today how you could approach and master EKS multi-cluster orchestration like we did at Hilti successfully. My name is Thomas Langer. I'm heading a DevOps team in business unit construction software at Hilti Group. And I'm based out of Liechtenstein. Juho, why don't you introduce yourself briefly as well?
Good afternoon, everyone. I'm Juho Kuusisto, working as DevOps architect at Hilti in Liechtenstein, where I help teams to adopt DevOps culture and to leverage cloud-native technologies. And then we have Kumudan.
Hello, everyone. Good afternoon. I'm Kumudan Kaliyarisi Sherarajan. I am a DevOps consultant at AWS, and I help customers build hands-on solutions on Kubernetes.
Thank you very much for both of your introductions. Well, who of you has actually ever seen one of these red toolboxes or even has used one of these red tools? Hands up, please. Amazing. I see a lot of construction enthusiasts. That's great to see. But who is actually behind that? Yes, it's true. It's the Hilti Group. We got founded back in 1941 by Martin and Eugen Hilti in the beautiful village of Schaan in Liechtenstein. We are a global system solutions offerer to the construction professionals. Our purpose is to make construction better by better products, better projects, and better services. In order to achieve this, one of our key ingredients is our direct customer relationship. Actually, the majority of our more than 34,000 team members across the globe in over 120 countries are in day-to-day contact with our customers to better understand the specific challenges that the customers face and to identify appropriate solutions for them. Through this and also other levers, we have been able to achieve in 2023 a sales of more than 6.5 billion Swiss francs, which is a fantastic result in our opinion. Now, innovation and product differentiation play a major role for us at Hilti Group too. And this is why we invest actually on a year-to-year basis more than 7% of our sales into R&D. All of this, for sure, is not possible without our strong foundation, which is our global team that lives our caring and performance-oriented culture, through which we also regularly get awarded by the Great Place to Work team, like you can see on the slide here too. But having talked now enough about Hilti Group as a total, let us try to better understand what we understand behind system solutions. When we talk at Hilti about system solutions, we always think in a combination of three different elements. The first one is our hardware, where we offer a vast selection of tools and solutions for the construction professionals. We combine this with our software that helps the customer to get the best out of their tool, but also to improve their operations. Combining this even more with the third element of our services, the customers can benefit from technical support for their projects, and even their tool park. Talking more about software, that's the main theme today as well, right? We do have from Hilti Group a software offering towards our customers that we tell construction software. Construction software at Hilti Group improves the customer productivity, their projects, and their processes. Currently, as part of our construction software, we are offering 4 different products. The first one is called OnTrack. This is an asset management solution that helps the customer to manage their equipment. Let's get here a bit more tangible and let me provide you an example for this. Let's imagine You are a construction worker working for a company called ABC Construction, and your location is in Winterthur. You get a task to go to a job site in Zurich to do some groundwork. For that, for sure, you need certain tools. Now in the morning, you grab your van, you load your van, and you leave the warehouse. When you arrive at the construction site in Zurich, you all of a sudden realize, damn, I forgot a heavy breaker that I need to complete my work today. That's a pity, isn't it? So in former times, what would you have done? You would have called your colleagues, the one after the other. Hey, hi John, how are you? You have potentially another driller? No, I don't have. I cannot do my work. So it's really a juggle to figure out where the exact tool is that you need. And this is exactly where Hilti On Track kicks in. With our solution, you can basically get notified when you leave with your van from the warehouse if you have, for example, all your equipment with you, or in case you need some additional tools, you can easily check in your mobile app where the next available tool is available so that you can actually organize a transfer to your job site and complete your groundwork for the day successfully. Having talked about this on-track solution, let's move on to the next one. This is Crew Center. Crew Center is a workforce management solution that helps you, for example, to manage your time and attendance on different construction sites. This helps you afterwards for the appropriate accounting for the job site, but also helps you to ensure that your workers are adhering to local regulations. The third product I would like to talk about is called FieldWire. FieldWire helps you to manage your job site. What does that mean more specifically? It helps you to manage your tasks and to collaborate on these tasks for the respective job site. Last but not least, we have an 4PS as well that covers the business management domain. And here specifically, we do have a construction-specific ERP system in place as part of our offerings too. Having walked you through these 4 products, you can nicely see that with our construction software, we are actually capturing and covering the most important elements in construction business. It's the equipment that you use to build, it's the workforce that is actually doing the work and building, it's the tasks to understand where you have to do what, and it's the business management solution so that you can make some business finally out of it. I walked you now through these 4 products and explained you what it is about. Let us look behind the scenes and let me introduce to you how we do actually develop these solutions. In our construction software unit, we are following a product-centric approach. That means each of the individual products I showed you beforehand has its own or multiple own product development teams in order to build the solutions. All of these products are then powered by a strong technology and platform area, where we heavily rely on existing services and capabilities to make the best out of the product development teams. I would like to walk you here through a few of them to give you a bit of a glimpse of what is behind that. We do use, for example, GitLab for Git and CI. We are using Terraform for infrastructure as a code to bootstrap our infrastructure. Obviously, as almost a de facto standard nowadays, we are heavily relying on Kubernetes to manage our workloads. On the observability side, we use Prometheus as well as Grafana. Being here today, I think it's obvious we're in strong collaboration with AWS, where we consume a lot of capabilities and services from, but also work together with Microsoft. Having such a platform and thinking it through from a technology perspective is actually really great in order for scaling, but also for resiliency and standardization reasons. Now, I believe we have been doing a lot of things great, but we also had to learn a few things. And here I would like to highlight to you today specifically 4 key challenges that we have been facing. All of them are in the maintainability area. and some of them might sound very familiar to you. So let us go through that. The first key challenge I would like to highlight is that we had a lot of different infrastructure components and toolings in place that actually had tight dependencies to each other. So we couldn't do atomic updates for one component and then another time for another one when it was required. That obviously led to the fact that we always had to bundle these updates, which obviously increased the complexity of the updates, but also the effort required to manage those updates successfully. Out of historic reasons, we did have also a lot, or better said, many customized cloud-native components. Some of them we even have written on our own. Having such a diverse landscape and customizations in place adds to the maintainability efforts too. Effective resource management is important for each company, in my opinion, be it for cost effectiveness or be it in regards to sustainability. And here as well, we had to do in the past a lot of manual interventions in order to really stay up to the mark that we have been targeting for. Last but not least, I would like to talk also about a challenge that you might have heard beforehand as well, or seen and observed. And here I would like to highlight that nowadays, cybersecurity is playing a bigger and bigger role in each company. I believe we have also different sessions today that have this as a key theme. Having such a cybersecurity area in place and so many cyber attacks basically on a day-to-day basis, a lot of the capability providers actually respond to that with accelerating their update cycles. So obviously, if you find a vulnerability, you would like to patch it and with that offer a new version to your consumers. This is something we have been facing too, and in order to not have the wrong security posture, we for sure followed that trend. In the end, that did result in additional maintenance efforts too, that instead of doing an update maybe once a month, we had to do it much more frequently. I've walked you now through a couple of key challenges that we have been facing. I guess you are now curious to hear what we made out of this. And for this, I'm going to hand over to my colleague, Juho, who is going to tell you more about this. Thank you.
Thank you, Thomas. So, with the challenges Thomas just presented to us, it was very clear to us that we needed to change. We needed to get better. We needed to improve the infrastructure platform, what we had. And with that, we said that, hey, now we are going to build a new version of our infrastructure platform. And to help us on that journey, we set down 3 design principles very early on in the process to guide us towards the solution that really addresses the biggest challenges we are having. The first one is rather obvious. We said that we will prioritize maintainability over additional new features. Okay, that's really easy to say, but believe me, it is really hard to follow. And to help us on that, we come to our second one. So when we looked critically into our existing infrastructure platform, it became obvious that it was way too complex to achieve the maintainability goals what we had in mind. For example, we had there still self-managed Kubernetes control planes in use, whereas nowadays managed offerings can do that for us much better than what we can on our own with cheaper cost also. And another example is that over the years, we had actually ended up in a situation where we had, for example, 2 different solutions for collecting application logs from microservices running in our infrastructure. And that just doesn't make sense, right? So, as the second principle, we really embraced the very well-known YAGNI principle. You aren't gonna need it. Meaning that we only add the features and parts that are actually used by our users, used by our development teams, and when they are needed. The third one was to prioritize and to prefer off-the-shelf solutions over custom-made implementations. And with off-the-shelf solutions, we mean here now both the commercial off-the-shelf options, but also open source software solutions. For example, we used to have, as Thomas also mentioned, a lot of our own customized components and configuration in the system. We had our own scripts and logic for bootstrapping any common services we want to have in every cluster. And we also had, I think, 3 different self-built Kubernetes operators for deploying our applications and managing AWS services as well. And for both of those examples, nowadays we have better solutions off the shelf. We can use very well-proven GitOps practices to manage the deployment of any common add-ons and tools on the clusters. And for managing the application deployments, we can use in Kubernetes, for example, just Helm, right? And for managing the AWS resources, we have the AWS controllers for Kubernetes. Or we can even use Crossplane for the more universal approach on the same. And underlying all these 3 things, we have cost consciousness. And cost consciousness for us means using common sense when it comes to costs. So we are not looking single-mindedly on the cheapest possible hosting cost available, for example, on AWS. No. Rather, we look at the total cost of ownership for the solution for the infrastructure platform we are designing. Let's go to the right direction. But also, when we really were looking at our existing solution, the one which had the challenges, we really also saw that there were a lot of good choices made when we were building that. And the 3 very foundational pillars of that existing solutions, we said that, hey, we will keep those. They're really solving our problems, and we are happy with them. The first one is Kubernetes. Our applications, our products, such as OnTrack and Crew Center, they are designed to be run on Kubernetes. Our development teams know how to build software to run on Kubernetes and in containers. And our site reliability engineers, they know how to troubleshoot any issues there may be in Kubernetes clusters. And maybe the most importantly, we as a whole organization, we are quite happy with Kubernetes. It is really solving challenges for us and doing a good job. The second one is GitOps. Now, how many of you are using GitOps today? Show me your hands. All right, almost half of the people. Let me try to summarize then GitOps really shortly to bring everybody up to speed. So GitOps is a process for managing your application deployments through Git, where you have declarative configuration of your deployment in Git repository from where the automation component running inside Kubernetes goes and fetches that configuration in a reconciliation loop, ensuring that the single source of truth, what you have in Git, is really also reflected in your environment. And why we said that that's important for us. We have multiple teams, multiple products, hundreds of people doing changes to our environments, from development environments to quality assurance environments, even to the production every single day. So having the robust process with complete change history is really a must-have for us. And Git brings that to us out of the box. Also, the declarative nature of the configuration with GitOps, it really helps our site reliability engineers to figure out any incidents there might be. They can just see on the Git, okay, how the system should look like and work from that. And the third one, multi-cluster approach. So multi-cluster approach, this was something we also had a bit of discussion. Do we really want to say that this is something we keep and set in stone very early on in the process? But in the end, we said, yes, multi-cluster approach is working for us. So having multiple clusters, separate clusters for separate products and for separate environments and teams, it is a way to isolate the clusters from each other. That way, we can be sure that there is no unauthorized access between the different clusters or even between the teams. And by having the multi-cluster approach, it also meant that, okay, we don't have to think about how do we operate multi-tenant Kubernetes cluster. There's nowadays really good, well-documented, proven ways to do that. But for us, saying that we stay with multiple clusters meant that it's one less problem for us to solve. And based on the design principles, the 3 foundational pillars, and our vision for the future, we set down goals for the project. And in total, we came up with these 8 goals that we said that, hey, these are something we really have to achieve with the new infrastructure platform offering. And now I will walk you through each one of these, starting from the top and going clockwise. So you remember the biggest challenges that Thomas presented, and the very first design principle we had, they were about maintainability. So it only makes sense that the first 2 goals are really numerical goals that we can concretely say whether we achieved or not, and they are really linked to the maintainability. First one is that we want to reduce the time we spend on setting up new Kubernetes clusters by at least 60%. You can imagine with the multi-cluster approach, there is new Kubernetes clusters coming quite frequently. And the second one, we said that we want to spend at least 80% less time on software upgrades, such as upgrading our fleet of Kubernetes clusters from one version to the next version. Moving forward, tailor-made solutions only for Hilti-specific challenges. So why this is important, why this is a goal? There are 2 aspects to this one. The first one, it's really about reminding us about the 3rd design principle, preferring off-the-shelf solutions. But also, with the goal, we highlight that we are completely fine in having tailor-made solutions for challenges that are truly specific to Hilti, that are not solved by others. And in the end, we actually did build one Kubernetes operator on our own to help integrating the microservices to our internal common Hilti IT services. Moving forward, no overlapping platform features. So you remember the example about having 2 different tools, for example, for the log collection. So that's something we just didn't want to see happening in something we are now building from the ground. Then, ARM and x86 support. So in AWS, you have 2 kinds of EC2 machines. You have the ones that are using AMD or Intel chipsets, and you have the machines that are using ARM chipsets called Graviton instances. And the difference is that software you have built to run on the AMD or Intel machines cannot be run on Graviton, and vice versa. And why we wanted to include this? Graviton produces for most of the use cases better price-to-performance ratio. And furthermore, the underlying hardware uses a lot less energy than the AMD or Intel instances. And getting those benefits is something we have been talking also internally for quite some time, but we just couldn't find a way to support both kind of instances in our existing infrastructure platform with reasonable effort. But now that we are building a new infrastructure platform, it's a no-brainer to have support for both kind of instances from the day one. And why both? Why not just move everything to Graviton? Well, as I said, the application designed to be run on another cannot run without some changes on the other one. So we have to do that kind of change gradually. So there needs to be transition period when your teams can use both kind of instances. And speaking about cost, also one of the goals we set down is that the AWS costs for this new infrastructure platform solution must not grow compared to the old one. And this is, in our opinion, a rather easy one to achieve, right? Just with the modernization of instance types, introduction of Graviton, and utilization of spot instances, this should be quite easy to achieve. And the last 2 months, they are more future-looking, grounded in our vision to enable further developer self-service and to work our way towards platform as a product model. Okay, but now with all the talk about the design principles, things we kept, goals we set, done, we finally arrive at the target high-level solution for the new infrastructure platform defined by the use of GitOps and EKS. And before I will walk you through the bullet points on the slide, I want to highlight you a few really important things about the solution. So what you see here is a hub and spoke solution with multiple AWS accounts and multiple EKS clusters, where the spokes are, in this case, called workload accounts and workload EKS clusters, and the hub cluster is the one which is responsible for managing the life cycle of the spoke EKS clusters and resources. And now, please listen carefully. If you have one takeaway from this presentation, it is this. So the unique thing we are doing here is we are deploying Kubernetes through Kubernetes. So we are deploying Kubernetes from the hub cluster, we are deploying the workload EKS clusters. And that's a big change from what we were doing earlier and what I bet quite a few people are doing. So rather than deploying the EKS clusters through the management console or our Terraform pipelines, we are now making it possible to deploy the clusters through Kubernetes control plane. And why is that important? Well, by making it possible to deploy the clusters and all of the related infrastructure through Kubernetes, we standardize both our application and infrastructure deployment to the same Kubernetes API model, to the same Kubernetes control plane. So now we simplify, see what I did there? It was the second principle we had. Now we simplify the solution what we have by having a one way to deploy both applications and infrastructure. And the third one, really important note, is that the workload clusters, what you see here, they are fully independent, standalone clusters in a sense that they manage everything deployed on them on their own. So even if the hub cluster becomes disconnected or is lost either temporarily or even permanently, the hub cluster, the workload EKS clusters will keep on running as they were. Okay, with generics behind, let's walk through the EKS cluster vending workflow what we have here. So as the first step, the site reliability engineer will go on, define the manifest for deploying the workload EKS cluster, and he or she will commit it to the cluster's Git repository, from where the GitOps operator running inside the hub EKS cluster will go on and pull the configuration and apply it on the hub EKS cluster. Then, as a second point, the hub cluster, or actually the operators running on the hub cluster, will take care of provisioning the workload EKS cluster, but also the workload networking components such as VPC, subnets, and whatever is needed. And as a third step to close the loop, the workload cluster itself will go on, or the GitOps operator running there will go on, pull the configuration from the Git repository and apply it on itself, meaning that now the workload cluster is really self-managing itself. And with that, the workload cluster is then ready to be used by the development teams to manage their applications and their services through Git in a GitOps manner. Okay, so now we have covered the challenge we were facing, the approach we took to address that, and the high-level target solution. Next, I will hand it over to Kumuran, who will then walk you through the more technical details on how did we actually make this happen? How did we turn this into reality? On to you, Kumuran.
Thanks, Juho. Hello, everyone. Let's dive deep into the overall solution. We would categorize the overall solution in three major parts. Firstly, vending EKS clusters. Many customers use infrastructure as code tools like Terraform, etc., to provision cloud resources. May I know how many of you are aware of Crossplane? Oh, I see many of your hands raised. During the designing phase, one of the main focus was to take the innovative approach to adapt infrastructure as Kubernetes APIs. Crossplane is an open source platform to manage infrastructure as code tools using Kubernetes APIs. That means we can define and leverage infrastructure resources like database, storage, networking resources declaratively. And that is what, like, we can spin up an S3 bucket using Kubernetes manifests. Doesn't that sound interesting? In the same way, we can create a VPC as well, and an EKS cluster too. And that is what we exactly mean by provisioning Kubernetes through Kubernetes. As Juho mentioned, we are using a hub and a spoke model approach, where the hub cluster is provisioned using Terraform, and we are using Flux to enable GitOps for our Kubernetes configuration. Before we actually start vending EKS clusters and provisioning EKS clusters, we bootstrap the workload accounts with core networking resources like VPC, subnets, NAT gateways, etc. Instead of having individual definitions of these core resources, we would group them using cross-plane compositions and form a single template, a single blueprint to provision core networking resources. And with cross-plane claims, we reference these compositions and provide parameters, define parameters like VPC name, CIDR ranges, etc. It's similar to the Terraform TF-vares that we define variables, right? And once we have them, the cross-plane controllers running on these hub clusters are then responsible to deploy the core networking resources onto those workload accounts. As you see, we have a QA account and a prod account, the QA being a single AZ setup, and the prod being with multi-AZ setup. So we can customize our cross-plane compositions based on the resources, number of resources, and the requirements we have. Moving ahead, once we have the workload account bootstrapped with the core networking resources, the stage is now set to provision EKS clusters. We would be following the same approach where now we would group the EKS cluster and its related resources into a different cross-plane composition. Like we might have a cross-plane composition to group EKS cluster, IAM roles, Fargate profiles, etc. And now with EKS claim, now defining parameters specific to the EKS cluster. Like we would now define parameters like cluster name, cluster version, etc. And like the previous approach, the cross-plane controllers running on those hub clusters would now deploy EKS cluster onto those workload accounts. You might see we might have one cluster or more than one EKS cluster per account, each managed by different teams. And hence, we have different cross-plane claims to define and manage those workload clusters. Moving ahead, how many of you are aware or have known about Carpenter? And that's huge in number. We all know that Carpenter provisions and scales worker nodes very fast. However, there are many other things which Carpenter does more than just scaling. Here, if you see, one of the main focus was to have, even though we would be having Flux running on all of these workload clusters, we would need worker nodes first in order to deploy the Flux, isn't it? That means we would need Carpenter onto those worker nodes, onto those workload clusters, in order to run Flux, right? This is the second part of a solution. How do we deploy Carpenter onto those workload clusters? If you see, the Flux running on the hub cluster points and reconciles everything on its own cluster. We enable the Flux running on the hub cluster to be able to manage and provision workloads onto those remote workload clusters. We use remote deployment approach for doing this. How do we do that? We provide kube configs of these remote workload clusters to the Flux instance running on the hub cluster. And now the Flux in the hub cluster is all ready to be able to manage and deploy workloads onto those remote clusters. And in that way, we deploy Carpenter with the Flux running on the hub instance to these remote workload clusters. One of the key design principles was to also have seamless and effortless cluster upgrades. Cluster upgrades, and this is the third part of a solution. Cluster upgrades involves upgrading cluster control plane, data plane, add-ons. And we all know the complexities it brings along with it, right? During the upgrades, we have to check the sequence, the dependency, the way it's upgraded. Like, for example, we have to first upgrade the add-ons version. And then we go ahead and upgrade the control plane. And then we go ahead and upgrade the worker nodes, in our case, which is managed by Carpenter. It all looks easy until we just have to manage one cluster. Imagine that you have to upgrade all of these things where you have 30 to 40 clusters. Doesn't that sound interesting? It's a bit difficult, right? And with here, upgrading the cluster control plane, here it's a bit easy because EKS being a managed solution, upgrading the control plane is just a matter of clicks. And in our case, we would just be updating the Crossplane claim with the latest version, and it does on its own. One of the key features of Carpenter that it automatically upgrades worker nodes. As soon as there is an update to the cluster control plane, when the cluster control plane version is upgraded, Carpenter detects a drift. And Carpenter, as soon as it detects a drift, it automatically starts upgrading the worker nodes on a rolling update basis. We faced a few hurdles during our implementation. One of them was to provision cloud resources using Crossplane conditionally. One such example was setting up a single AZ in non-production environments and having a full-fledged multi-AZ in production environments. This was one of the hurdles that we had during our implementation. How did we overcome that? So we had two sets of different compositions, one Crossplane composition for setting up a single AZ and one set of composition for setting up multi-AZ. But as Crossplane functions now available in a stable version. I think during our implementation it was not available in a stable version, but now with Crossplane functions, we can have a single composition instead of managing multiple compositions. We can have a single composition and we can have conditions to provision cloud resources. And this is what we plan to implement in our upcoming days. With all that talk about Carpenter, Flux, and Crossplane, it's not just all this. It's a big umbrella. The overall multi-cluster GitOps orchestration platform holds multiple open source controllers all tied together to form a strong internal developer platform to enable developer self-service and also to achieve cloud-native operational excellence. With that overview, I'm sure that you are all excited to know how this approach brought forth immense success and remarkable success for Hilti. Without further ado, I would like to hand over to you, my colleague Juho, to dive deep into the success metrics. Thank you.
Thank you, Kumuran. So, how did we do against the goals we had set in the very beginning? To highlight a few things, well, in overall, as the title says, the new platform solution really exceeded the goals we had set in the beginning. And the key highlights, for example, you remember the very first goal we had there, the second goal, was to improve the time we spent on Kubernetes upgrades by reducing it at least by 80%. And we are now actually seeing 85% reduction on the time our team needs to spend on upgrading our whole fleet of Kubernetes clusters from one version to another. We are down from several weeks to a few days to do that across the whole platform. Also, the other goal there was that we wanted to reduce the time to set up a new cluster by at least 60%. And now with the new platform solution, we are seeing 10 times improvement in the time to set up a new workload cluster, which translates to about 90% in reduction in the time. So we are now down from multiple days to mere hours to provision a new workload cluster. And also looking towards the future, enabling more developer self-service capabilities. With the new solution, with especially help of Crossplane, it's 21 times faster for us to enable the development teams to use any new AWS services in a manner that is compliant to Hilti's cybersecurity and operational policies. And underlying all these things is that we are actually seeing 20% reduction in the AWS bill, what we are paying, mainly driven by the use of Graviton instances, spot instances where we can, and ensuring that we have the GP3 storage type in use also in places where we didn't have it before. All right, with that, we are now at the end of our presentation. Thank you very much for your interest. Please leave us feedback through the application by filling the survey. If you want to talk with us, we'll be behind the stage there somewhere for a few minutes after the talk. Come to talk to us, and you have our contact details there also that you can look up us on LinkedIn. Thank you very much and have a nice Summit day.
Thank you.